Don't panic, be confident. Today we are learning about 1 proportion z intervals. So what is a 1 proportion z interval, you say? Well, to start out, the formula for a 1 proportion z interval is p hat plus or minus z star times the square root of p hat times 1 minus p hat over n. Now remember, as a side note, that if p hat is not given, then you should use 0.5 for p hat. The z star is the symbol for the critical value, which is the number of standard error away from the estimate. The margin of error is made up of the critical value and the standard error. The total distance equals 2 margins of error, which makes a lower bound and upper bound, as you can see here. Another side note, in your calculator, to get this test, you will hit Stat, then go to Test, and hit A for the 1 proportion z interval test. Now time for why this is important. 1 proportion z intervals can be used to check the reasonableness of claims about the parameter. It is used when a parameter is unknown. 1 proportional z interval is a method of inference. Now it's time to take it step by step and work out a problem. The first word problem is, a major metropolitan newspaper selected a simple random sample of 1,600 readers from their list of 100,000 subscribers. They asked whether the paper should increase its coverage of local news. 40% of the sample wanted more local news. What is the 99% confidence interval for the proportion of readers who would like more coverage of local news? Let's work it out step by step. P stands for parameter. Let's write our parameter in the correct context. We are estimating the true proportion of readers who would like more coverage of local news. Now A, for assumptions. Remembering that the conditions are the normal condition, the independent condition, the 10% condition, and the random condition. The random condition is the simple random sample of 1,600 readers. Readers' opinions are independent, which represents the independent condition. Now for 10% condition. 1,600 times 10 equals 16,000. There is at least 10 times the sample of readers in the population. And lastly, the normal condition. N times P and N times 1 minus P must be greater than or equal to 10, which shows that the sampling distribution is approximately normal, as shown here. Now N, the name of the interval, the easiest part. We will be using the 1 proportion z interval test. Moving along to I, the interval, which is the lower bound and the upper bound. After plugging in the numbers to your calculator, remembering that your x is 0.4 times 1,600 and that it must be a whole number, your calculator will give you your interval, which is shown here. And lastly, C, conclusion and context. Don't forget to write it in context. We are 99% confident that the interval from 0.36845 to 0.43155 captures the true proportion of readers who would like more covering of local news. And we're done. That wasn't too hard. Now let's put it all together with a new word problem. Don't forget all the steps. A survey of 1,000 Californians reports that 48% are excited by the opportunity to take a statistics class. Construct a 95% confidence interval for the true proportion of Californians who are excited to take a statistics class. Now to work it out. P. We are estimating the true proportion of Californians who are excited to take a statistics class. A. People's opinions on statistics are independent. We would assume subjects were randomly selected. There are at least 10,000 Californians. 1,000 times 0.48 is greater than or equal to 10, and 1,000 times 0.52 is greater than or equal to 10. Therefore, the sampling distribution is approximately normal. N. We will use a 1 proportion z interval test. I. The calculator gives us the interval 0.44904 to 0.51096. C. Don't forget to write it in context. We are 95% confident that the interval from 0.45 to 0.51 captures the true proportion of people who are excited at the opportunity to take statistics. Now let's do a quick assessment question. What is the correct 1 proportion z interval formula? Now take a second to think of your answer. If you got the answer B, then you're correct. Hope you enjoyed this lesson.